Can you pull that question back up again?
Yeah.
So the question that we were having was, it's 50 and then 17, so it's 67. So the reason why we determined it was going up was because the 80 newtons pulling it down is greater than the 50 newtons pulling it this way, right?
Mm-hmm.
But our question was, what's pulling it down is actually 50 plus 17, because the frictional force is also pulling, like it's like a circular reasoning type thing. Do you see what I'm saying? Because say for example, instead of it pulling 80 newtons down, it was 60 newtons pulling down, right? Then we would make the comparison that 60 is greater than 50, so it's moving this way, and then the frictional force is moving this way. But in reality, if you look at then 50 plus 17, that's 67. So 67 would be pulling down, and 60 would be pulling down. So then it's like a contradictory logic, right?
Yeah.
So we had that question. So I searched it up. So what happens is, for a certain range of masses, the acceleration is 0. So in that case, if it's 60 and if it's 60 going down and 50 going this way, you would the way to do that is, first you would assume it goes this way and that thus it's being pulled up, but then you take into account the frictional force and then you say, okay, now it's 67, and that's contradictory logic, so therefore the acceleration is 0. So when that happens, if it's for a certain range of masses, the objects don't move. So if the frictional force plus the mg sine theta is greater than your other weight, then you assume that for that, in that weird case, that they don't move.
Oh.
Now, yeah, if it was like maybe 50 and then 80, then obviously even then, what if it was something like 60 and what if it was like something like, I don't know, 70 newtons pulling this way and 60 newtons pulling this way. Once you take into account the frictional force, that's also weird, right? So when you get that contradiction, basically you say that they don't move. It wouldn't have any acceleration.
Oh.
I don't know if I have that website. I can show you that website. Or
Hopefully she doesn't give us something like that. But
yeah, would she give us a question like that?
I don't think so, because usually that's kind of a very weird scenario.
Yeah.
But that's it was just a question that we had, and I don't know, it was really bugging me, so that's why I just wanted to clarify.
Yeah, I remember I didn't even know what you and Neha were talking about. I was so confused, but now I understand like what you were asking.
Because it's a concern, right? Like, how does the 67, if that was 60,
You ask her?
Huh?
Did you ask like Ms. Raja?
Yeah. She gave an explanation which I didn't understand at the moment. And then she said it at the end of class, and I wrote it down, and I kind of understood it, and then I searched it up and did the math a little bit more, and then it started making sense to me.
Interesting.
Okay.
Yeah.
Okay, let me stop sharing. Okay, so what type of problem do you guys want to do?
Maybe we can do.
Do you have a preference, Mohan? I don't know. MG said he doesn't care. I don't know.
Yeah.
Do you have a preference?
Maybe that of option like objects in equilibriums, like the ones that are being like held up. Like I have to look at the question numbers.
Oh, yeah, that one was weird. You're right. I know which one you're talking about.
Is it on homework 3?
Yeah, homework
Yeah.
3.
Okay. Oh no, what is wrong with my word?
Oh, like number 14.
Yeah.
The one where it's like the 3 forces and those.
Because
I don't know why.
I was assuming a lot of stuff, and so I was just like, oh, like I
Oh,
would.
this one? Oh, this is the one we did with Miss Rajan too?
Yeah.
Yeah.
Okay.
I would just assume that like F1 or the cosine, sorry, the sine of F1 would be equal to the sine of F2, right? Like you would just assume that, and then vice versa with the cosine, and then you would say that 2 times F1 would be equal to the weight, or 2 times F1 sine theta would be equal to. That's what I. It's still like I'm not like I don't feel solid about it, so.
It's kind of like you just have to work through it. You know, once again, it's like it's the thing where it's like there's no. I don't think there's like a general like way to do it. This
one is really weird because it's hung by the ropes, but then there's also the point, and then there's also like a lot going on.
What I confused at first was I confused the tension of the mass with the tension pulling down on the dot. And that's what confused. So I always try whenever there's two objects, even if I'm not worried about the second object, I still draw the free body diagram for that, because otherwise I get very confused.
Drawing a diagram is just really helpful.
It helps a lot, especially when it comes, honestly, with inclines. Like the second I draw a free body diagram, I understand it completely. But with these questions, like, I don't know, even when I draw it, I still feel like I'm doing something wrong.
Can we just go through this one more time? I just feel like going through it another time would help me.
Yeah.
Okay. Okay, so first, I guess we look at, I don't know, first thing I looked at was like F1 and F2. And so they both have the same angle. And so, so we know that the horizontal components are equal. So that means like F1 cos theta is cos 30 is equal to F2 cos 30. So that means like F1 equals F2. So we know that. And so, okay, this part I was a little bit confused about just because I didn't really understand when she was talking about it. Okay, so then I'm reading what I wrote down. So she said 2F1 sine 30 equals mg.
Okay. So the thing is, the net force, so because the horizontal forces are acting in opposite directions, so they cancel each other out. So we don't have to worry about those. And then, because like you said, F1 sine 30, the vertical components, F1 sine 30 is equal to F2 sine 30. Or sorry, they're not equal to each other. I'm sorry, we don't know that yet. F1 sine 30 plus F2 sine 30 equals F3, right? F1 sine 30 plus F2 sine 30 equals F3.
Yeah.
F3, and F3 is the tension.
Yeah, F3 is tension.
So it'll be weight, right? Pulling down. So that's mg.
Why is it though?
Sorry?
Like, why is it 2 F1 sine 30?
Oh, because we said that they cancel each other out, right? Which means that F1 cos 30 equals F2 cos 30, like you said. So if you divide both sides by cos 30, you'll get F1 equals F2. So you can make that substitution in.
You're asking why it's 2 F1 sine 30?
Yeah.
Aleena is
that's what I was asking.
Yeah. So basically, so if it's an equilibrium, then your upward force is equal to your weight, right?
Yeah.
So you know that weight is just simply a force in the downwards direction. There's no vertical horizontal component. It's just simply downwards, right? So the weight, so the mass times the gravitational pull is going to be equal to 2 times the F1 force, because we're assuming that they both have the same sine theta, right? You get what I'm saying?
Okay. Yeah, that makes sense.
The two of them would be equal to the weight pulling it down.
Okay, yeah, that makes sense. Okay, yeah, so then we know F3 is the tension, and in this case, it's just equal to the weight, which is mg. So then we can make the conclusion that F1 equals F2, G equals F3, which is A.
Okay.
I think there was one I was confused about that I wanted to ask.
Sure.
Okay, a little bit of a confusion.
Yeah.
So this was just like a lot because Miss Raja was like, okay, so block A is 50 and block B is 30. So in this case, would block B just be like hanging? Is there no, what is happening here? Because
block B is still pulling down. Block A is still going to move to the right. The only time, because think about it, right? What's the issue is, the issue right now in an incline, you have to think about, am I going to pull down this way or pull down this way? A can't go down. There's no motion of A that's pulling down. So B is the only thing that's going to pull down because of gravity. Okay. A can't go down because of the normal force, right? So B is the only thing that's pulling down, and it has to go down because unless A was just so massive that it wouldn't pull down.
Okay.
Okay. So in these types of questions, like when you have a pulley and then you have two like objects, so you're assuming that tension is the same and that acceleration is the same.
Yeah, because they're one system, so they're moving at the same rate.
Yeah, at the same time. Okay.
And this is why. Okay, so Aleena, I think I have a better answer to your question about how do you know that B is going down rather than A? It's because of the dynamic friction, kinetic friction that's going on here. And earlier the problem said static friction, which is why I got really confused, because if you have static friction, that means it's not moving. So it depends on the problem. If it tells you that it's kinetic friction, then you know that it's moving. And there's only one way it can move. You can't work against.
Is dynamic friction kinetic?
Yes. There's a lot of different terms, and there's also sliding friction. It's very, yeah, it's a very dynamic term.
Just like, so once you have like static friction, you can automatically assume that the frictional force is equal to the force, like the tension.
It depends on the situation. In this case, yes. No.
This is kinetic friction.
No. If it
says.
Like on question 11, you know how it said static friction?
Yeah.
So, and on a question, wait, yeah. So you know how does it?
Yeah, it says static friction.
Okay, yeah. So then you would assume that the tension is equal to the frictional force.
Yes, because net force is 0. So that's the only, yeah. Okay. Yeah.
Yeah, thank you.
Okay. Okay. That's what I was confused about this one.
Okay.
Let me see if there's another one. I was looking at.
I think they weren't too confusing, but I feel like they were just really, really strange to me. Questions like 17 and 18, because they didn't explicitly give you a lot of information.
Okay.
You have to do some math trick work with those.
Yeah, I figured it out, but that's because I read something online. But honestly, I would not have ever figured that out if I didn't. Because with these, like you can't write just force or gravity or weight. You have to write like mg and ma in order to get them correct.
Yes. Yeah.
Yeah. So should we do this one?
Yeah.
Sure. Yeah.
Okay. Should I use the whiteboard? Let's see. Okay, I'll use the whiteboard. Okay. No, I've never used the whiteboard before. Okay, what's the problem?
Do you want me to read out the numbers? I can do that.
Okay, I have it kind of.
Okay.
Where did the whiteboard go? Oh, it's right here. Okay. So we have a 20. Oh, this is going to be rough. Oh, wait. Oh my God. Can I draw it with my hand? Oh my gosh. Wait, that's so exciting.
Yeah, you have a touch screen.
Yeah, I have a touch screen. Okay. So let's just do it in, oh wait, no, let's do it in purple. Okay, so a 25 Newton crate slides down a frictionless incline that is 25 above. Okay, so let's just gonna do this. So this is 25. Okay, that is 25 degrees. And then this is also 25. Wow.
But it's newtons, so it's not mass. That's the only thing.
Yes. You know what? We're just gonna do that.
What I do is I usually just, if I'm gonna write it, I write I don't put the weight inside of the box. If I do write anything inside the box, it's the mass.
Yeah, I was just about to say that. Oh, that was really bad. Okay, let's just say 25 newtons. Okay. The magnitude of the normal force of the incline on the crate. Okay, so normal force is this. Fn. Wow, that was bad. Okay, so what we need to do here is it gives us the weight. We don't have the mass and we don't have the acceleration. Okay, wait. Okay, wait. So normal force in this case is. I don't want to do this wrong. I haven't.
So draw out all the forces first. I think
Okay,
that'll
yeah.
help.
So then I'm just gonna like. Okay.
Yep. Yeah.
Okay. I'm just gonna write. Actually, no. I'm just gonna leave it. I don't think I have space to write it. But okay, so this would be mg cos theta.
Yep.
This would be mg sine theta.
Yep.
So we have mg cos theta, mg sine theta. Okay, so
They're just asking us about the normal force, so we don't need to know mg sine theta.
oh yeah.
I realize now I was talking about questions 18 and 19, not 17 and 18.
That's okay. We'll still go. I think
Yeah.
it's a good introduction to the next because that's what.
Okay, so mg cos theta. So now we need to find m, correct?
Yes, but why find m when you already know weight is mg, and just plug in the weight as 25.
Oh, okay. So then we have 25 cosine of 25, which equals, what does this equal? 22.7 about, right?
Mm-hmm.
23. Yeah. I just put 23.
22.7. Okay, so this is mg cos theta. So this is the answer.
Yeah, normal force. Yep.
Okay. Oh my gosh, I was doubting myself so much.
Oh, you did a good job.
Okay, clear. Are we good?
Yep.
Yeah.
Okay.
I don't know if 18 or 19 is harder, but I just feel like they're good to work out just because they're like
Yeah.
on the test.
So, no, yeah, these are good. I have to go through all of these again, but okay. A block slides down a frictionless plane that makes an angle of 30 degrees with the horizontal. Okay. Okay, wait, give me 1 second, actually. I think I heard the doorbell. So I will be back.
Okay. Is it okay if we go through it? Or I mean,
Or oh yeah, we should have asked her before she left.
it's okay. It's recorded, so she can come back.
Yeah.
Okay. So what is it? It's 30 degrees.
Yes.
Why can't I draw straight lines? I can't. Unless I have some sort of ruler. Okay. 20 degrees. That's 30 degrees. Whoops. 30 degrees with the horizontal frictionless plane. So, and we have some sort of block. We don't even know what that block is. How fun. Okay. So,
That's
we know that essentially here's our weight, mg, but we don't know, we're going to break it up into its, we're going to resolve it into its, whoops, wrong direction, vertical and horizontal components. In this case, this is in relation to the incline, of course. So this would be mg, why am I still drawing the arrow in the wrong way? The arrow is this way, there we go. And this would be mg cos theta, and this would be mg sine theta. And we would also have the normal force up here. Cool. Okay.
Oh my gosh, please, what is this drawing?
I can't draw straight lines. Like I can't. And it's so, my drawings are very messy. Okay.
Okay, so a block slides, okay, the acceleration of the block. Okay, so to find acceleration, okay, so we have, sorry, you can keep annotating actually.
We were just trying to do the free body diagram with, so the weight,
okay.
And we resolve the weight into mg cos theta, mg sine theta, and then we have normal force mg cos theta going up. And it's frictionless, so we don't have friction. That's,
yeah.
Okay. Now we can go to
Okay, so this,
yeah, go ahead.
Okay, this is the free, okay, so acceleration is going to be the horizontal, like components or whatever. So we have.
So it would be net force over mass, right? But in this case, the only net force is the horizontal.
Wait, say that again?
So generally, you would say it's net force over mass, but in this case, the net
Yeah.
force is just the horizontal, right?
Yeah. Yeah, the net force in this case is just mg sine theta, correct? Okay. Wait, let me rewrite this. I don't know why I wrote this. Okay, so we would have, let me just write this, just F net over M, no, right?
Yeah.
Okay, sorry. So that would equal, in this case, mg sine theta over M. So mg is...
We don't know what mg is.
Oh, that's fun. Okay.
You cancel your m's.
Oh, yeah. Okay, so... Oh.
Yeah, so these are the weird ones where you have to do the math tricks and not the... You have to, like, really...
That's so strange. Okay, so g sine theta. Also, have you guys been taking 10 as g or 9.8?
I always take 9.8. I'd rather have a precise answer because I have a calculator. I mean, if I didn't have a calculator, I would take 10. But like, because I have a calculator, I'm not gonna.
Either or, and it really trips me up because with some of the questions, doing 9.8.
Oh yeah, she uses
by like 7, like between like 10 or like 20 newtons. Your answer, I'm like so off, but like why am I so
If you
off?
take sig figs properly, though, the answer should come out to be the same because that's So that's one way I check usually.
Okay, I guess let's just use 10 so I can write it easier. Okay, sine. What is it? 30.
Yeah.
That's 5, right?
Yeah, 5.
Okay.
4.9 if you use the other one.
Bro, Aleena, 9 is so much more trippy. Like I was literally about to cry. It was so bad.
Okay, so this one was pretty good.
Yeah.
Okay.
Once you know this rule, 19 doesn't seem that bad. But before I didn't know the rule and like how to split weight into
okay, I'm gonna clear. Okay. 19.
After doing those problems, I learned that the best way to do these problems is rather than substituting them early on to treat it like algebra and then substitute everything at the end.
Yeah.
Unless you like can't go ahead at all without substituting.
Okay, at a playground, a child slides down a slide that makes a... Oh, no, that's too steep. I don't like that. Okay.
Literally all my triangles look the same. I'm not...
Yeah. Out of 42 with a horizontal direction. The coefficient of kinetic friction for the child sliding on the slide is 0.2. I'm just going to write that here.
Yeah.
Okay. What is the... Oh. I'm just going to draw the child as a block. I don't really care.
Yeah, I do that too.
Okay, so then we have mg, and we have here mg cos theta. Here we have, oh, those are not straight lines, mg sine theta. And then here we have fn. Okay. Oh, and then friction will be this way, right?
Yes, upwards.
Okay. Okay. Okay, so this is the free body diagram. Okay, so the coefficient of kinetic friction for the child. Okay, what is the magnitude of her acceleration during her sliding? Okay, so we have to find acceleration. So we're finding horizontal. And so that means, okay, wait, I'm just gonna write it like this for now. This would be mg sine theta minus F friction, right?
Yes.
Okay.
That's assuming this is positive. Or I mean, we're just looking at the magnitude, right? Yeah.
Yeah. Okay, so that means we have MA, oh wait, we're running out of time, equals mg sine theta minus Fn. Yes? Okay.
Yes.
So what are we finding here? We're finding acceleration.
Yes.
Okay. So, hold on. Okay, so Should I divide by m on both sides?
Yeah, I did this. I think I did this algebraically. That's probably the best way to do this.
Why is there so many? Please now. She said, "Where's the Gov quiz?" We've been talking about this. Okay, so, and then did you separate it up? Like, did you do like g sine theta minus?
Oh, and then I found I did Fn is mg cos theta, right? And then you can factor out an m and then divide.
Fn is mg cos. Oh, okay. Wait. I'm gonna erase this right here.
Yeah.
That's like they're really good to do, just so like on the test, like you know to not write, just simply write weight or just write like force. Like you break it down.
Okay, so then actually wait, hold on. I'm just gonna erase this then here.
Yeah.
So then we have Fn is mg. Oh my gosh. Give me 1 second. I'm turning off Slack notifications.
They get really annoying when they just pop in from the side.
Yeah, there's too many from Anna and Neha. Okay. Okay, mg cos theta.
Yep.
All right, so then m. So then we have a equals g. Oh, what was that? What was that, Aleena? Okay. My hand keeps touching the mouse pad. A equals g sine theta minus mu g cos theta. Right? Okay.
Yep.
Which equals, I'm losing space, so g sine theta is just 10 of 42, right?
Yep. And now I just put this all into my calculator.
Okay. Minus, what is this?
0.2.
What is this? Okay. 0.2.
Oh, I'm saying, yeah, the mu is 0.2 times 9.8.
Times 10.
Oh, sorry, yeah. 10.
Of 42. You have 5.2, right?
I got 5.1, but that's because I used 9.8, I think.
Okay, yeah.
But yeah.
So, okay, so that is the magnitude of her acceleration. Okay, so 5.2. So are we all good? Okay, so I'll just try. I don't know if we're gonna need this, so I'll just write it up here. No, I'm not gonna write. We don't know if it's positive or negative, so I'll just write 5.2 up there, just so we don't forget. Oh, wait, I just realized I erased the free body diagram.
That's okay, I think we remember. Unless you want to bring it back, that's fine. Either way, it's fine.
Yeah, can I do that?
Control Z, if you hit Control Z a few times, it might work.
Ah,
Yeah.
okay, let's erase all of this business.
I wish it was like, do you remember the smart board where they did the whole circle thing and then the duck
yeah.
down?
I remember that. I also think that was so cool.
Yeah. I remember that day we got like a 3-hour recess because they were installing the smart board. That was in second grade.
I remember that. Okay, so 5.2. Okay, so if she starts from rest, how long is the slide if it takes 4 seconds to slide down? Okay, so we can use x equals ut plus 1/2 at squared. Are we, wait. In this case, are we assuming that it's positive?
Well, x is in the direction that you've made positive, right? So we've decided that this is positive, so.
Okay.
Unless you wanted to say this is positive, in which case your 5.2 would be negative. A negative 5.2. It just depends how you want to look at it.
Okay. So then u is 0, so we have x equals 2.64 squared. What is that? 16 times 2.6.
Whoa. Wait. Where?
Yes.
Oh, sorry. 5.2 divided by 2.6. Sorry, I got that. Sorry.
Okay, sorry, my bad. I should have written that down.
No, you're fine. I just wasn't working as fast as you were. My bad.
Oh, my bad. I just didn't feel like using my calculator, so I was just. Okay, so 41.6. Is that what we got?
Yes.
41.6.
Chairs.
Okay.
Cool.
Okay. Any other ones that we want to do?
If we don't have, I mean, we can do other ones, but if we don't, can we try a problem that from organic chemistry tutor or something? I just want to try something I haven't seen before.
Okay.
That's a good idea.
Okay. Okay, let's do this one. Let's start from the beginning. Okay, so this, actually, wait, okay, hold on. Do you want me to do this or does someone else want to do it? Someone else can do it if you want.
Do it. I just kind of want, or someone else can do it. I just wanted to work through it.
Okay, I can do it.
You
Okay.
can do it. We only have 3 minutes left, so you should just do it.
Yeah.
Oh, wait, yeah. Rip. Okay. Okay, I need the whiteboard. Okay. An 8 kilogram. Oh, I was just doing this one actually. Okay. Ow. Okay.
Okay.
I just hit my knee on my desk. That really hurt. Okay. An 8 kilogram mass is placed on a 30-degree frictionless inclined plane. Okay, stop there.
Okay.
Okay. So we have this. We have 30. Oh, I don't like it. It's too steep. I can't draw my things correctly. Okay. Okay. And then we have 8 kg is attached to a pulley connected to, okay, let's draw the pulley. I'll try my best. That's how I draw it.
Yeah, I can't draw pulleys. They're like all squiggly.
I know, yeah, mine as well. Connected to a hanging mass of 5 kilograms. Okay, A. In which direction will this, oh, wait, actually, let's draw all our forces first. So we have down, we have mg, we have,
In this case, whatever there's two, I write M1G or M2G.
Oh, yeah,
Otherwise,
yeah.
I get confused.
yeah, me as well. I just, okay, m1g, down m2g. Okay, and then we're gonna have this, and then this, which is oh wait, I should have written it the other way.
Oh, do you want me? I usually make the one on the left M1 and the one on the right M2, but it doesn't matter.
Okay, let's just do that then. Okay. Let me draw this real quick. M2G, and then we have, this would be M2G cos theta.
Tension starts from like the pulley and it faces towards the object, right?
Oh wait, oops.
No, it's pulling against. It's like towards the pulley.
I'm gonna use a different color for tension.
Also, we have like 1 minute left, so I have a feeling we're not going to get through this problem. Like, not to.
Can I save this or something?
Yeah, I mean, it'll automatically, like, the recording will save and it'll start converting.
Oh, I mean the whiteboard. Will the whiteboard save?
Oh, the whiteboard?
Hold on, wait, let me just see if I can, like.
Interesting. Okay.
Hopefully it does. I think it does.
Are we just going to reuse the same link to join?
Yeah, this
Okay.
is my personal meeting room. So
Got it. Sounds good.
Okay, let me just stop sharing then.
Yeah, let's just go ahead and end this because I hate it when like it just automatically cuts us
Oh,
off.
it disappeared. That's fantastic. I'll just redraw it, I guess.
All right.
Okay.
Okay.
All right, let me stop the recording.